In this video, we're going to look at the heat of formation and using the heat of formation to calculate enthalpy for reactions. The standard enthalpy of formation, or standard heat of formation, is given by delta H subscript F naught. The standard heat of formation of a substance is the enthalpy change for the reaction that produces 1 mole of the substance from its elements in their standard state. The naught on the delta H F naught is for standard state. We can combine the heats of formations for the products minus the sum of the heats of formations for the reactants to come up with the enthalpy for a reaction. The equation delta H equals the sum of the coefficients of the products times the heats of formation for the products minus the sum of the stoichiometric coefficients of the reactants times the heat of formation for reactants. Let's look at a problem. Determine the standard heat of combustion of ethanol, C2H5OH. The combustion reaction, ethanol in the liquid form plus 3 moles of oxygen in the gas form, will produce 2 moles of carbon dioxide in the gas form plus 3 moles of water in the liquid form. We can use the formula, the sum of the products minus sum of the reactants, to calculate the heat of combustion. So delta H equals, for the products, the coefficient 2 times the standard heat of formation for carbon dioxide plus the stoichiometric coefficient 3 times the heat of formation for water minus the reactants, the heat of formation for ethanol, plus the stoichiometric coefficient for oxygen 3 times the heat of formation for oxygen. We can look up the standard heats of formation in tables. So if we look at the standard heat of formation of carbon dioxide gas, we see that it has an enthalpy of negative 393.51 kilojoules. The heat of formation for liquid water, minus 285.83 kilojoules. Heat of formation for ethanol, negative 277.69 kilojoules. If we look at the standard heat of formation of oxygen, that's 0, because oxygen gas is in its elemental form. We then plug these numbers in and we'll have delta H equals 2 times negative 393.51 kilojoules plus 3 times negative 285.83 kilojoules minus the sum of negative 277.69 kilojoules plus 3 times 0, which of course is 0. We do the math on that and we come up with a combustion of ethanol is equal to negative 1,366.82 kilojoules. As you can see, by just knowing the balanced equation for the coefficients and looking up the heats of formation for each of the compounds, we can use this to calculate the heats of combustion or other enthalpies for reactions.